My name is Brad Heintz. I am a partner engineer at Facebook. I work with the AI team, specifically with PyTorch. If a partner engineer is an unfamiliar job title to you, that's not unusual. But basically my day job is making sure that developers get the most they can out of PyTorch, whether that's in research and development or production or wherever. If you are kind of new to PyTorch and wondering what it is, it's an open source framework for your machine learning and AI projects that will take you from research to production. It has a number of sort of pillars to it design-wise. It offers both eager and graph-based execution. It was one of the first frameworks to have like a really mature eager computation mode where it would actually track your computation graph during your forward pass and then automatically compute derivatives for you during your backward pass. But we can also skip the automated gradients and execute in a graph mode as well for production inference. PyTorch neural networks, they're written in Python. So they can be fully dynamic. They can have complex control structures and loops whose length you don't know until runtime and all that good stuff. We have tools for distributed training. We've had data parallel training for a while. With PyTorch 1.4, we now have experimental support for model parallel training. Hardware accelerated inference, so everything's, all the magic in PyTorch doesn't really happen in Python. It happens in libtorch, which is a compiled, optimized library written in C++ and targeted for CPUs, NVIDIA GPUs, and there's also experimental support for Google TPUs. So if you want to mess with your PyTorch notebooks in Colab, feel free to try that out. And finally, simplicity over complexity. We try to make the happy path the short path. If there's kind of one thing that I keep hearing about, PyTorch in the wild, is that developers seem to get a kick out of using it. Iteration times are faster, and you don't have to learn like a separate domain-specific language to build your computation graph and all that. We try to make it as straightforward as possible to implement your ideas and try them out. PyTorch is an open source project. There are over 1,200 contributors from around the world, from companies like Microsoft, Toyota Research, Airbnb, Salesforce, institutions like CMU, MIT, Caltech, et cetera. So this is not just a Facebook project. This is a worldwide open source project. We've seen huge growth in usage over the past year, as well as growth in the community, in the PyTorch forum on pytorch.org, in Reddit groups and Facebook groups, Slack channel, et cetera. The stat at the bottom of the screen there is one of the interesting ones to me. Of archive.org papers that mention a framework, a machine learning framework, PyTorch had like almost 2.5x or more than 2.5x growth last year in citations. Which kind of, I think, speaks to the grassroots enthusiasm for the framework. So a few weeks ago, we released our 1.4 update. Every 3 months or so, we do another point release. And January was 1.4. And so I'm going to share with you some of the newer stuff that was in 1.4. I'm going to look back to a couple of 1.3 features we've improved on as well. I think the big things to highlight with this release are first off, PyTorch Mobile. So in 1.3 last October, we introduced the PyTorch Mobile runtime, which I'll talk a little bit more about. It's basically like a drop-in library you can put in your iOS and Android projects. You can feed it a PyTorch model, and you can do inference performantly on your mobile devices. And the big improvement in 1.4 is selective compilation. So now, if you're very sensitive to binary size, you can set it up where only the operations that your model needs get compiled into the library when you ship. So that's kind of nice. I had mentioned distributed model parallel training. So I think a lot of us are familiar with data parallel training, where every one of the nodes in your cluster gets a copy of your model, and they each get different batches of data, and you kind of collect their answers at the end. Model parallel training, which is becoming more important with models like GPT-2, is where your model won't necessarily fit in memory on its own, and so you have to kind of slice it layer-wise and put different chunks of the model on different nodes. So we're offering experimental support for this now, which is enabled by the RPC facilities baked into Torch.distributed now. By the way, when you hear me use the word experimental, that doesn't mean we're just messing around with it. Everything I talk about here, we're committed to in some form. Experimental really just means the API isn't frozen yet. It's still kind of evolving. So what else we have? Java language bindings. So as part of our work on Android for PyTorch, there was sort of an opportunistic side project someone took on to make Java bindings for PyTorch. It's inference only, Linux only right now, but if you're a Java shop, you might want to check that out. Learning rate schedulers now, they used to have a race condition if you try to use two of them at once, like if you try to use a step and an exponential decay in the same topic, the same epoch. Only one of them would win, but now you can kind of compose them in a natural way. Is anyone here still on Python 2? Anyone? Sorry, Eli. Yeah, pour one out for Python 2. This is the last release that is going to promise any kind of support for Python 2. Now, besides the PyTorch core framework, we also offer what we call the domain libraries, the domain APIs for computer vision, for NLP, and for audio work. These are Torch Vision, Torch Audio, and Torch Text, all of which also got their point numbers bumped. In Torch Vision, models support quantization now. I'm going to be talking about the quantization feature in a few slides ahead. All models are now able to be exported in TorchScript, which is sort of our graph computation language, or graph mode language for production deployment. We'll be talking about that soon as well. Mascar CNN is now exported to Onyx. So if you're doing instant segmentation with Mascar CNN and you need Onyx to deploy, you can do that. Torch Audio also had some improvements. More and more of the high-value operations and transforms from Caldi are being rewritten and optimized for Torch Audio. There are new data sets in Torch Audio, LibreSpeech and Common Voice. And actually, all the data sets in Torch Audio have been revamped to use the data set parent class from PyTorch. Which is great because now it really reduces the memory impact of loading up that audio data set and kind of regularizes the abstraction we use for data sets across the libraries. So yeah, new data sets and improved data sets in Torch Audio. SOX is not a mandatory dependency now. And again, more operations within Torch Audio support TorchScript for performant deployment. And Torch Text, new bindings for tokenization, for sentence pieces, more new data sets, and blue scoring metric, bilingual something understudy, what's the E? I forget, but it's sort of like becoming a de facto metric for language to language, or translation between human languages, and that's baked into Torch Text now for measuring the performance of your translation models. So I'm going to go a little deeper on a few features that crowds have told me are of interest before. Starting with PyTorch Mobile. So the general idea here is if you have a model that you would like to improve someone's experience in your mobile app, the kind of common way in a lot of cases is to actually take the input, do a network round trip to your model living on a server, and get your answer back that way. Deploying a model to mobile, unless you're using one of the like OS-specific frameworks, is kind of a pain. We've tried to make that as easy as possible. Here, you would build and train your model as you normally would in Python on cloud hardware or whatever. You'll export it to TorchScript, again, more about which later, and then load it up in your native environment inside the PyTorch runtime. I actually ran this at this demo at a booth at Scala in San Jose, and people wouldn't believe that the MobileNet model I was running was actually working that fast. Like it would identify my shoe or a computer or a coffee cup. And yeah, all happening on device. It was kind of cool. You have a question, sir?
Yeah, what is the size of the model on mobile?
The size of the binary? Wait, the binary or the model itself? Actually, I don't know the answer to either off the top of my head.
The size of the app, but I'm more concerned with the size of the model. The mobile optimized model.
It was MobileNet v2, so you can probably look up how many parameters that has, quantize it down to 8-bit int, and make an educated guess. I don't know the number off the top of my head, though. Okay. Anyways, to include the mobile runtime is literally one line in your pod file for CocoaPods and iOS, or your Maven or Gradle file if you're living on Android. So, model parallel training, I had also mentioned earlier. So this is becoming more important with the big NLP models. I feel like right now we're kind of seeing the NLP revolution that happened to computer vision a few years ago. But it seems to always be happening with really, really big models. And to the point where a lot of people are finding that they have trouble fitting these models into memory on the hardware they have. So we're offering you the option now to slice up the model and distribute it across nodes and have the computation graph work across physical hardware. So this comes with an RPC framework that you can use even if you're not doing distributed training. Supports running functions remotely, referencing remote objects. All the autograd magic that I happens under the hood, where you do your forward pass and it computes the backward derivatives for you. That works across nodes with model parallel training. And there are examples on PyTorch.org to show you how to do this with LSTM and reinforcement learning. Java bindings, I'll just mention briefly. We have a Python front end, we have a C++ front end, and now we have sort of this experimental Java front end as well. Only for inference, so no autograd support for training, and only on Linux at this time, but expect the Java support to grow with time. Besides the core framework, we also have some tools that we've developed within Facebook, either Facebook AI Research or AI Applied Research. Have built these. One is Classy Vision. So if you're doing an image classification problem and you're trying to figure out, okay, what is the right model to use, the right loss function, et cetera, Classy Vision might be a great tool for you because the workflow for an image classification problem is pretty well known, and so we basically sort of commoditized and parameterized it, where now even the model type can be a parameter to this classification training run. It's also integrated with PyTorch Elastic training, so if you are wanting to have an elastic cluster that will take up as many spot instances as you can afford, it'll do that for you as well. This is actually something we use inside Facebook for weekly supervised CV training. Urge you to check it out. Also, refresh is DetectorOn. DetectorOn is now DetectorOn 2. It includes the latest models for the main task, all the sort of Matskar CNN and its descendants. You'll do panoptic segmentation as well, dense pose, et cetera. The idea here is that DetectorOn 2 is sort of your one-stop shop for all your segmentation needs. So that's DetectorOn. Quantization. So this was a feature that we rolled out with 1.3 last October, but the performance and operator support has been improved for PyTorch 1.4. The basic notion here, of course, is that we do most of our work with 32-bit floating points. But could we get similar or almost as good results if we went down to 8-bit ints? And there's an answer to that in the next slide. Besides just the memory savings, so going from 32 bits to 8, of course, you'd expect 4x change in your memory footprint, both resident and bandwidth. But a lot of hardware architectures like AVX2 include optimizations for integer math. And so you'll tend to see a compute speed up as well if you quantize your model. So to give you an idea of the effect of that, these are three different well-characterized models that were trained and then quantized with different workflows. But you can see, we have what, two CV and one translation problem here. Minimal changes in accuracy, but significant speed ups in compute time. So continuing on the theme of tools, outside of PyTorch core, also with 1.3, we introduced Captum, and this has also been improved as part of the 1.4 rollout. So Captum is a tool for model interpretability. And so you can see here on the right-hand side, there is a picture of a zebra and a question, what's in the picture? And to the right, you can see that it has highlighted all the most zebra-ish pixels for us, as well as highlighting what it thinks are the most important words in the question. So this is an example of Captum acting on a multimodal model to tell you what were the elements in the input that gave me this prediction of zebra with 0.6 confidence. Now, Captum will help you attribute your output to features of your input. You can attribute your output to the activity of hidden layers within your model. And you can even attribute the activity of individual neurons within your model to an input or to earlier layers. Currently, we're doing just gradient-based approaches, but if you want to use like perturbation or other methods of assessing the significance of an input, you can do that.
Is that only for vision?
No, it's so we have visualizations baked into it for CV and for text, and so you can see here the visualization for text. Yeah. Where it's saying, I think the blue is contributed to the answer, and the red is these words pushed away from the answer, as it were. But there's also, for generic inputs, there's also a sort of stock visualization for that.
Is it an attention mechanism or something? Please repeat the question.
Yeah. You were asking if it's an attention mechanism?
That's what it looks like from here.
Right. So what it's actually doing is tracing backward through the graph and understanding for a particular output, like what are its most interesting gradients through the graph and what input features do those relate to. So it's not attention. And Captum itself is not a model. It's a tool for interpreting models and telling you, helping you understand the activity within them.
So it's looking at the weights of the neural network which most matter. This is what it's doing?
Not just the weights, but it's more about the computation path through. He was asking if the weights are what it examines, but it's actually kind of the gradients. Yeah.
Is your output also like, do you output some numbers that if the person wants to do other?
Yes, absolutely. So these two slides I showed you about Captum actually came from a longer series of slides where they show code for doing this with your model and the outputs. And yeah, you can get numeric answers out that you can do your own visualizations with or whatever. Okay, and so we're close to the end of what I have for you. I want to point out some resources if you want to go and learn more. The first is pytorch.org. This is the one-stop shop for all things PyTorch. It'll tell you how to install it. Full documentation, tutorials, including on most of the topics I talked about today, like quantization, distributed training, all of it. If you're interested in Classy Vision, that's got its own website, classyvision.ai. Likewise for Captum. DetectorOn 2 lives on the Facebook Research GitHub. So if you go to github.com/Facebook Research, you should find it easily. And then if you want to get your hands dirty with the code itself, of course, there's a GitHub for that. So that's what I have for you. Does anyone have questions I can answer before we move on? Yes, sir.
So you talked about RPCs, those many nodes. I'm a small core guy. I've got one computer with a couple graphics cards in it. Does it work for that? I mean, that would be an RPC.
Yeah, absolutely. You can have multiple. Oh, sorry. The gentleman here was asking about distributed training and whether or not a single physical machine with multiple graphics cards could be used with distributed training, and the answer is absolutely yes. You can have multiple training nodes on a single physical machine if you have the hardware to support it. Yes, sir.
In the beginning, you asked if anybody from the crowd had done a really cool implementation of PyTorch or visualization of it. Have you seen any really cool ones that we should check out?
What have I seen that's cool lately? I mean, some of the stuff that Autodesk is doing. I don't know if they use PyTorch for the yet, but there's a generative design tool that they have that I thought was pretty dope. Do you know if that was PyTorch under the hood? You know?
I can't remember.
Okay, I don't know if that was PyTorch, but it was pretty cool. I
know
God, all the coolest stuff I know about is still under NDA, so I'm sorry. Actually, if you go to PyTorch.org, there's a model hub there where you can see like some of the models that people are putting up for others to use. It'd be a good place to investigate. Yes, sir.
There's some interesting news I read Twitter, which was about, I didn't see that mentioned, PyTorch supporting 3D graphics.
Yes, I haven't had a chance to mess with it myself yet, but the PyTorch 3D library for like doing ML on 3D geometries. Yep, that's new and very cool. To your question.
iRobot is insane.
All right, I'll check that out. Anyone else? Yes, Alexa.
When you show the zebra, right, and so the like characteristic zebra points, can you just kind of briefly how is that like, because based on training, like is it based because zebra can be in different backgrounds, is it different zebras separate horses from tigers, from cats, like how do you define this characteristic?
Well, so Captain makes available multiple strategies, but right now all of them involve measuring the gradients through the computation graph. So we're going to basically, from the steepness of the gradients for a particular output, you trace a path back to the input features that are most interesting. Does that get to your question? Yeah. I didn't come prepared to go much deeper on it today, but we can have another conversation if you want. All right, anyone else? Yes, sir.
What's the name of that library that contains all the vision models that you showed just a couple slides
Oh.
ago? Yeah, DetectorOn.
Whoops. You know what? Is that it? Yeah. Classy Vision.
And the one after, DetectorOn.
DetectorOn. So Classy Vision is the library that sort of parameterizes your image classification problems. And then DetectorOn 2 is your one-stop shop for all things image segmentation. Anyone else?
So are those libraries, or those are basically libraries?
Yeah.
They're not,
Yeah.
Like,
That is correct. But they're built on top of PyTorch and things that the community has found useful.
Are there pre-trained models we can find with this, or are those models we train from scratch?
For Classy Vision specifically?
For any of them?
It's funny, I was just messing with Classy Vision with this. So Classy Vision comes with sort of its own versions of a lot of the models you find in Torch Vision. So your ResNets and your VGGs and all that good stuff. It doesn't have the pre-trained ones, but there's a workflow where you can take a pre-trained model, wrap it in a Classy Vision style model, and feed that in. So the answer is yes, it takes a little extra work.
Makes sense.
Yeah. Yes, sir.
Facebook has a plan of building some notebook or some kind of infrastructure where how Google has where you can run them on GPU. So like him, I don't want to spend a lot of money on the cloud training these models. Do you know if Facebook plans to provide some kind of infrastructure where you can train them?
So the compressed version of that question is, will Facebook train our models for free? No, the slightly longer version of that is tools like Colab allow you to do some work on GPUs or TPUs. Are we going to offer anything like that? The answer is right now, no. But of course, you can run PyTorch in a Colab notebook. In fact, most of the tutorials on PyTorch.org have a Colab link up top if you want to go in there and mess around. I think you can't really do long training runs that way because Colab will kick you out if you're not paying.
We can also cover those types of questions more once we get to the stage
Emily will have all your cloud computing answers.
We will cover those questions when we get to
All right, anyone else? All right, one more, sir, yeah.
So I liked your characterization of where you can use Python and everything. Is there anything more you can see to address?
The two? I mean, off the top of my head, no, I think get your hands dirty with both. I think that's what everyone should be doing when they're picking a tool for a project. Get your hands dirty with both and make a choice. That's my level of confidence in the product. I'll tell you to try the other one too. So, all right. Okay, one more, and then I think Alexei wants to move on. Yeah.
What do you think of Julia and its appeal to machine learning developers and framework and stuff?
I understand the appeal. I don't think it's quite there yet. Longer conversation, but yeah. All right, Alexei, thank you all for your time and attention.